Alright, so I made this for friends and neighbors, and then I thought that I may as well show it to you. Some history from 1960s. This is going to be largely based on the wonderful article at Perfect Circuit, and I'm going to post a link down in the description. In the state of New York, Robert Moog built his first synthesizer system, and it was modular, as you can tell by the photo. Robert was not a musician himself, so he consulted with his colleagues about many musical decisions, and what ended up happening is that system had a keyboard attached to it, and it later turned out to be a huge commercial success because many people nowadays know synthesizers as something with keyboard, right? Around the same time, in the state of California, Donald Buchla, who was a musician, built his system. Now, Buchla and his colleagues had a different mindset. They were looking for ways to create new and experimental music. And for example, on this photo, system has quite an exotic touch plate controller. Well, at least exotic for that time. Now, I'm telling you this because on your journey into modular, you may encounter terms such as East Coast synthesis or West Coast synthesis. And these are not mandatory. These are not dogmas. However, if you hear East Coast, think that it's usually based upon subtractive synthesis and may or may not have a keyboard controller. And if you hear West Coast, then it is usually an experimental approach to music creation, inclusion of exotic controllers, lack of them, and may be based around generative patching. All right. Modular today is primarily a Eurorack standard developed by Doffer Music Electronic in 1995. Here I have, I think, a quite reasonable example of some DIY modules, and we're gonna look at the one in the back. So it has a metal plate, set of rotary knobs, set of inputs, set of outputs, and even metals, and even a metal switch for some parameter, but there is no marking on the plate, so we don't know which one. And on the back there is a board with all the electrical components and a large power cord going somewhere backwards. Okay. And here's an example of in a full assembled Eurorack system. I think that's a great example because it has different modules from different manufacturers, and all the power cables are inside of the case. So yeah, this is it. What we're going to use today is VCV Rack, which is already version 2, developed by Andrew Belt in 2016. And it is a virtual modular synthesizer platform that simulates your rack modules. It's available for all the desktop systems such as Windows, macOS, and Linux. And even if you're an open source purist, there's even a fork called Cardinal. And if you're on iOS, there is a fork called Mirac. And I'm going to post a link to those down in the description. Okay, so signals in VCV and in all modular systems. Audio can be heard when played. Frequency range from 20 to 20 kilohertz. Control voltages. Modulate parameters of other modules. Waltz per octave signals represent pitch or a note. Increasing voltage by 1/12 will raise pitch by 1 semitone. That is tonality. Gauge signals carry on and off. 0 volts represent off. Positive voltage, typically 10 volts, represent on. That's turning something on and off. Trigger signals are short gates, usually around 1 millisecond, that cause an event, such as the percussion hit or some other event. And finally, clock signals are triggers played at steady tempo in order to set musical timing of your patch. But in the end of the day, ultimately, any signal is a voltage. So here I have a signal path of a common subtractive synthesizer. Think East Coast. It may look complex, but it is actually very simple. So in the beginning, we have a sound source, which is an oscillator. and we can plug it directly into the output set of speakers or monitors, and we can hear it. Keyboard is not our sound source. Keyboard just triggers an oscillator to play a certain note so it can be heard. An oscillator would oscillate a wave such as sine wave, triangle wave, sawtooth wave, pulse wave, and it produces audio output. But in typical signal path for subtractive synthesizer, oscillator would go first into the filter, which is a part of sound shape and stage. Now, what filter does is it subtracts or removes certain frequencies from oscillator to shape or to sculpt the sound. And after that, sound goes into the amplifier, where amplifier sets the volume level, which is going to be outputted into the set of speakers. At the bottom of the slide, we have a set of modulators. These can modulate parameters in many different ways, but typically in a complete or already built synthesizer system, you will encounter something such as low frequency oscillator or an LFO, which is oscillating low enough so it cannot be heard. It would modulate a pitch of an oscillator, so it would create a vibrato effect. Or LFO would modulate a cutoff frequency of a filter. You may even encounter a noise generator modulating a cutoff frequency of a filter or some other parameter. And typically for an amplifier, you would have an envelope. Envelope is basically an envelope of 4 stages, which modulates or tells amplifier how it should output volume during those 4 stages. And I actually have a dedicated slide for an envelope. A final slide. So ADSR envelope consists of 4 stages. First being attack time, second being decay time, third being sustain level, and fourth being release time. So when you press and hold the key, volume of that key is going first to go through the attack time stage until it reaches that peak volume. Once it reached that peak, it's going to go through the decay time, volume is going to decrease until it reaches that set sustain level. And it is going to stay on that sustain level while you're still holding that key. And only after you release that key, the volume level of the note is going to go through the fourth stage, which is the release time, until volume completely fades away. So yeah, that's pretty much it. Now let's jump into the VCV Rack and hopefully we will get something sensible out of it.